Hi, I'm an old guy and I do maths. Today we're looking for the turning points of a function, and the function that I've chosen to look at is this one here. It's a cubic. Now, generally speaking, the turning point of a quadratic is really easy to find because quadratics are symmetrical. In order to find the turning point of a cubic, or some of the higher functions, we have to resort to calculus. We differentiate the function. Now, there are videos on how to differentiate in the playlist. So if what I'm talking it sounds like a foreign language to you, have a look at those. Anyway, let's go ahead and do this. We're going to differentiate this function, which is a nice, easy job to do. The differential of it is 3x squared minus 8x minus 7. Now, what has this got to do with the turning points? Well, the turning points of a cubic are where the gradient of that cubic is 0. And what a differential gives us is it gives us a rate of change. So, if we put those two things together, the differential of this cubic, when this equals 0, so when the differential equals 0, it gives us a rate of change of 0. If we can solve this thing for 0, we will find the x-coordinates of the points at which this thing has its turning points. So, we differentiate, that's the easy job. Then we have to solve this, and it's an unpleasant looking thing. So what I did was I resorted immediately to the quadratic formula, and I'll just run through that very, very quickly here. I pop in the various values, so I've got 8 plus or minus 64, which is b squared, minus 4 times 3 times negative 7, which are the constituent parts of this, all over 6, 2 times that. Tidy that up a little bit, and I get 8 plus or minus the square root of 64 plus 84, which is 148. So now, if you're a little confused about how I get to here, here it is, 148. The square root of that is 2 times 74, which is 4 times 37, so that's 2 root 37. That's that quickly. Okay, right, so what I get as a result with some tidying up is I get that x is equal to 4 plus or minus the square root of 37 all over 3. And what I have done is I've approximated that on my trusty calculator. And so very, very roughly, as in this is not an exact value, whereas that is an exact value, the turning points are when x is equal to 3.361, let's say, or negative 0.694. Okay. Now, here is my imaginative sketch of the original function, which I drew earlier, and I drew it before I'd done this work. So what you're going to witness is the fact that my drawing is not anywhere near to scale, and it's pretty inaccurate looking down here. But anyway, what we have is I factorized it off camera too, so we've got the points of intersection on the x-axis, on the y-axis, and when we join the dots we can get a rough impression of what this thing looks like. Now the turning points are here somewhere, and what you can see here is that one of them is at negative 0.69, so I'll just pop that in here, negative 0.69 we'll say, we'll do it to 2 decimal places. Now when I place that value into this equation, when I place that value into this equation, I get 12.6 So this coordinate, the coordinate of this turning point, is negative 0.69, 12.6, and that is achieved by solving the differential of this for 0, taking one of the solutions and putting it back into this to get that. Now, the next one, which is evidence that my drawing skills are really not up to scratch, this point here is 3.36, let's say. Okay, so there's 3.36. That's the x-coordinate of this turning point. And to my shame, when I put that into this equation, I should have drawn this with a much, much deeper curve on it, but never mind. You do get points for getting the numbers right. And as I say to many of my students, if you get the numbers right, you'll get away with a lot. Okay, so if we put this value into this cubic, we get this. And so our turning point, reimagined, is 3.36, negative 20.75. So, a very quick review of the process. Differentiate this, solve the differential for 0, put the solutions for the differential of 0 into this original equation, and you will get these turning points. Thanks very much for watching. I hope this was helpful. See you next time.